Welcome back to the Circuit Revival, where today we're taking a look at this Jam Soundstream Plus turntable. I've actually repaired one of these for a friend in the past. It was quite interesting. It needed a stylus replacement, which was quite easy, but the actual amplifiers for the speakers had blown because it's got internal speakers just in this grill section here. So that they needed swapping out, and it all worked absolutely fine. So I've got another one. This one's a bit interesting. So it has a sticker on here that says, when plugged in to power, plug started to smoke. So it should be an interesting one. Obviously, we're not going to plug it in to begin with because that sounds a bit risky, but we'll try and get it out of this massive box. Might finally give me a reason to actually tidy up this desk because there's actually no room currently. Okay, here we go. Just got it out of the box. It actually looks really clean. They've not put it back together very well, and the stylus here is probably broken again. It'll probably need replacing given the state of that. But it looks absolutely fine. I think it does smell a little bit of smoke though, not like smoking or cigarette smoke, but yeah, like as if something had gone boom a bit in there. So they're quite easy to get into. It's just a case of undoing all of these screws at the bottom here. So this unit I bought off eBay. The seller was actually selling 3 different ones. There was 2 no powers and 1 with a faulty speaker. I thought the no powers would be a bit more interesting. So I know you can actually get this lid off, but last time I tried to take it off and the other one I worked on, these clips broke. So I'm actually just going to leave it on and just undo all of these screws at the bottom instead. Try and clear some of this space up so it doesn't scratch up all the plastic a bit. What I might do is just get a towel or something, just put underneath it just so it doesn't scratch that top too much. There we go, so that's just on a tea towel now. Hopefully stop it from kind of scratching the surface up too much. So we'll start just by undoing all of these, and then this board at the back just comes out nice and easily afterwards. I'm guessing there's obviously a short on the power rail. I don't imagine it would smoke otherwise, but we'll double check that. So normally I'd say it'd be good to verify the fault first of all, but given that they're saying that the plug started smoking, I don't really want to plug it in, potentially causing more damage to the unit, but more importantly just any damage around here. So it could be that that fault was wrong. If they were selling multiple, there's a chance maybe they sent the wrong one or put in the wrong one, but seems unlikely. So we'll just start by undoing all of these screws and then seeing if we can see anything. I'm guessing if something started smoking, I imagine there's potentially something a bit clear that's broken under this. Tell. So here we go, that just lifts up, so I'll put this base just off to the side and I'll have a quick look and just see whether there's anything immediately that stands out on this board. So I'll just zoom in for you guys a bit and we'll just have a look. So these were the 2 amplifiers for the speakers that needed replacing on the last one, this one here and this one here. But overall I can't really see anything on this that stands out other than maybe this chip. Just get this into frame for you. This chip here looks a bit fried. So what we might do is just get the multimeter out, double check the power connector itself and see whether that's showing a short. And we'll go on the negative and the positive of the power adapter there. So absolutely nothing. It's not beeping, which means that they're not connected. We'll take a look at that chip under the microscope either way, and I might be tempted to then plug this in and see whether there's actually a problem with it smoking. See if maybe it was actually just labelled up incorrectly. Okay, try and just get this set up a bit. Okay, so here we are under the microscope. This is that chip that we were looking at. It doesn't actually look as bad under the microscope as it did through the eye here, but you can kind of see in this corner it's sort of got this white on it, which I wondered whether originally was sort of like charring, but hard to tell there. We'll have a look just around at some of the other bits and see if there's anything. So this is the output for the speakers again. Looks like maybe just factory flux. We'll have a look up the top here near the power connector. See if there's anything. Seeing whether that is the case. Let's start near the top here. So again, a bit of factory flux on this. And then here's that chip that I was talking about that threw me off last time. You can see those bridged pins there. But when you actually take off the chip, it turns out that this pad is actually connected to both those. You can sort of see here currently, but I think actually all of these are there. So that's not seated very well, but I don't think that would cause the problem. Taking a look at that, I can't see anything that stands out that makes me think it might be the issue. There's a slightly sketchy looking diode on there, which we can have a look at. But overall, it all looks pristine, so I don't think we might get I don't think we'll get any more information unless we possibly try getting some power into this. So I'll just try diode mode on that sort of like diode in the middle there. It doesn't look it's sat down very well, and there's a bit of weird solder just hanging off of it there, so we'll just double check. Now I believe it's one of those things that if we do, we should get a reading one way but not the other. So, well, that is sort of all over the place, but idling about 0.9. It is in circuit, so I don't know whether that causes any issues. And then if we go the other way, it does give. Can't tell. Does look like it does just give open line, which which shows that possibly is right. So we might just need to put some power into this and see if it does anything. I'll just have a quick look around off camera first of all before I do that, and then if everything looks fine, we'll jump in and possibly just use the bench power supply to put some power into this. Okay, so I can't see anything on that side of the board, but there is obviously some things on the other side. So what we'll do before we try adding any power to this is we'll just undo this back board, which allows us to flip the main board over here and have a look on the other side. So if I remember correctly, there's a bunch of capacitors and stuff on there. So overall, like as far as the device goes, it's quite nice to repair. You can get into it easy enough. You can see things pretty easily. So I believe we just undo this, which releases it off the main chassis here, and then I think this will just flip over. Now if I remember correctly, the leads are quite short on this, so it is quite hard to get it out, and it sits on a post, so we've just got one screw here. So you just need to remember that the silver one is the one that goes on the board there. The rest are all the same. And then this just lifts out. That looks like I didn't need to undo all that anyway. That board comes off the front there. So we should be able to have a look on the other side here. And here's all those capacitors that I was saying. So we'll just take a look at these and see whether any of them look like they've bulged or that there's a problem with them, but saying that they also all look absolutely fine to begin with. No, I don't see any problems there. So the power just comes into here, so we could double check on here just to make sure that there is no short on the main power rail. So this is the 2 points, it would show there. Which it doesn't, so I don't think the main power rail does have a short, so there is a chance that maybe they packaged the one with the faulty speaker in this box. So I'll just quickly double check what the rating is for the plug. So it's 7.5 volts at 1 amp and it's outer ring negative, center pin positive. So I suppose we can just double check that quickly to make sure that maybe something within the factory's not wired it back to front. Maybe they put the wires in wrong and the negative goes to the wrong place, so it should go. So the red wire is on this side, so we said center pin positive, so if we touch the center pin here, trying to make sure, it should go to there and not there, and if we tuck into here now I might get both of them negative, and yeah, that's just touching the inside there. So the pin's the right way around, so we'll set the bench power supply to 7.5 volts and we'll see whether this comes to life. Okay, so that's 7.5 volts at 1 amp there. We should be nice and careful with this, but the negative is that side and the positive is that side. Okay, so it's not drawing anything at all. So it goes to 0.25 amps and then drops all the way down. Hold up, so I think I might be being a bit silly here. There is the power switch that wasn't on, so the power switch is now on. We'll try that again with the power switch on, because I'm guessing it goes into the board and then back out to the power switch, and that's where that problem was. So we'll be careful again and we'll keep an eye out for anything. Just make sure that's in, which I believe is on. Okay, so that is drawing, but I don't think I have any lights on the front which should come on. So it goes straight to 1 amp, but it doesn't take the full voltage. So what I might try and do then is see if I can get my negative lead onto the actual power connector here at the back, and then I'll have a hand free to try and get the thermal cam out and see if anything's getting warm. We're touching there, so that's just my hand. Okay, something's getting warm and it looks like that diode. I think it's just here. And it's still showing heat now. Just check around the rest of the board, see if there's anything else. That's just the power lead itself. Heat is still coming. Is it from that diode? Okay, let's power back in again. It does get very localized. What's that, about 40 degrees? So is that touching something it shouldn't? What I'll try quickly is we'll try the IPA trick. Try and see if we can see this. So if we get the microscope just over the top. So this is the component here. You can see, I did say a little earlier, it looks a bit weird. You see it's kind of got this like brushing on it. Looks like it's kind of been broken. And you can see, is it this bridge? Is that bridge not supposed to be there? Is that the problem? Alright, just try and get this into focus. So can't quite work that out, but is that maybe not supposed to be bridged there? Or does that follow the track? Maybe it does it like it follows the track actually. If I just get my tweezers, if we look underneath it, it looks like you might actually be able to see the green that just runs down into that. So maybe that's not actually a problem. But we'll try and get some IPA on it and then see when we put the power in whether it just evaporates straight off. So we'll try and flood it so that it's nice and clear. So we'll apply power now. Yeah, so you can see that gets really warm very quickly. And it just evaporates straight off. Now, I'm guessing it's this and not this component next to it, which could be some kind of like voltage regulator or something, so it could be either, but we'll just have a look again and see if we can see. So it definitely looks like it goes from that diode first. We'll get that off and see what the issue is. Damaging. Okay, that came off quite easily. Especially as you can see on this that there's actually glue here. So these components are actually glued down, and I think they're wave soldered, I think is the term that's used for it, where they then run just a wave of solder over the top. So we'll just take a look at this diode then and see whether there's anything immediately that stands out to us with it. So I don't really see anything massively wrong with it, but we'll try test it on diode mode again and see if there's any problems. I'm just trying to see if I can find some blue tack or something, because I know what ends up happening with these is they end up flying out into the abyss when you try and do this, so I'll try and be careful. So it's not measuring anything that way, and it is giving us a reading that way, which makes me think maybe the diode itself isn't the problem. But it seems odd that the pad itself would have been slightly lifted and that was what's heating up if it wasn't, but I guess it could have been the symptom of a problem, like it, rather than actually the problem itself. Now I don't imagine that's going to work with that out of circuit now, but I'm just going to test it again with the bench power supply and see whether it does anything. I'm guessing that diode might just stop it from working full stop, but by taking that out it might show the actual problem instead if that diode itself wasn't the problem. No, it doesn't look like it. Well, what we'll do is we'll get the actual unit just out of the way slightly and we'll try and test this diode a bit further. I'll do a little research, see if there's an easy way of checking it. So here it is, here's the diode itself. Try and see if I can see anything that stands out with it that might prove that this is in fact the problem. Can't see anything there, unless it looks maybe a bit split. I'm still a bit confused by these sort of like scratches, but again they could just be surface level. What's this though? Is that damaged there? No, I think that's just where it's bent round. So the legs are bent underneath it. It's a bit interesting that they bend the legs underneath. So maybe, if that's how it works, maybe when they've bent the legs round it's broken something internally. Hard to tell. But I'll try and measure it again. So what they do recommend is using some blue tack or something just to hold it in place. So I'm just going to have a look quickly and see if I've got any. Okay, I couldn't find any blue tack or anything, but I have got this masking tape, which I'm hoping if I stick that down and then stick this on it, should be enough to hold it in place, that whilst we're testing it, it doesn't disappear. So I'll put my multimeter back into diode mode here, and I'll just shout out the readings. So that does give open line. And this side gives 1.2 and climbing. Sort of all over the place. Settled down 0.6 up to 1.1. So let me just show you that on the camera to begin with. And that time it's given a steady 0.5. Maybe I just didn't have a good connection. And then this way, open line. So maybe that's not the problem. Okay, so I'm back. I've just been looking around the board, looking at some bits, trying to work out what it was, and basically following the circuit around where that diode was. And what I'd seen on the board was that it goes to a cap here on this side, so I checked for shorts there was no short. But then on the other side I can see it goes to another cap, which is just here. Let's see if we can come in a bit more. Just here. Which is on the other side of the board, and there's a chance that some of you guys actually saw this earlier on in the video. I have to double check and see if it was clear, but the angle I was looking at this from, it was not clear at all. But as soon as I've turned it over and looked at it from the other side, it all became a lot clearer. So you might be able to see it in there, but what I'm going to do quickly is just move over to the microscope to make it as clear as I can. And basically the diode that was getting warm there was actually a symptom of the issue, or potentially it wasn't that diode itself, it was actually the diode on this side of the board just showing through. But obviously I didn't think to flip the board over and try it again, where I think it would have made it very clear if that was the case. So I'll just get this set up. This is clear in the video there, but you can see where our problem is. For one, you can see just a big crack down the side of that diode. The whole thing has just gone completely boom, and it's also melted into the actual main power connector itself. So there's a chance, if it's gone all the way through, it's actually touching this this positive lead here. So I suppose we can test that with the multimeter, see if that's the case, but if not, it is likely just the fact that that diode has gone boom. So we need to get that old one back on and get this new one off and get a replacement, and we should be all good. Flip this back over and we'll get that diode back on. I've double checked back through the footage, and fortunately it's quite clear which way that diode went on. There we go, that looks nicely done. And then we'll move down to just below that. So here we can see on the board is the other diode symbol. So this is the back of the diode that's gone kaboom. So we'll just get a bit of leaded solder on this to help reduce the melting temperature. That trace is knackered really, isn't it? So I can't really tell if it was entirely me or whether the heat had sort of destroyed it a bit. The fact that that other pad had come up slightly makes me think that it possibly was actually as a result of the initial damage. So hopefully this should just lift up and out. There we go, that's one side. And then the other side should hopefully come out a bit easier now. Our diode has just snapped clean in half. That's just how catastrophic that failure was. And this is what we're left with. Just show you this. So there is the diode there that's just gone boom. As with most things, I don't have any of those in stock right now, so I'll have to just order them in. So it'll be a couple of days for me, but then hopefully just a couple of moments for you. We'll get that diode replaced, and hopefully it'll work. Okay, so it's been a couple of days, just a couple of moments for you, and the parts have arrived. So I have here a replacement diode. They came in a pack of 100 for a couple of quid from China, so I figured I'd just get a load. From what I've been told, these are quite common ones, so seemed worth getting a bunch of them. So we'll just replace it and then see if it works. Now obviously I don't know if this is going to completely fix the issue, because at this stage I don't know whether the blown diode was the fault or whether it was sort of a symptom of the fault. So we'll try and get it in and see if we can get it in place. We'll probably need to rebuild some of these tracks slightly anyway. So might need to use a bit of wire to get that done. But if we just take the diode and then place that back in. So I've double checked some photos, and the grey end, which we can see just on here, if we do that, there's a grey end and a black end. The grey end points towards the connector over here. So we'll just place it back through. So that's in place. I'll just bend these legs out slightly just to hold it still, and let me just move this back in to the camera there for you guys. What I'll probably do is jump under the microscope for this and make it a bit easier for you guys to see, and should hopefully make it a bit easier to deal with. You'll be able to see sort of where those traces have sort of broken away and are sort of no longer there. So one of them looks like it is kind of connected through, but the other side's not. So if we take a look at the top here, you see it's supposed to connect to this pad at the top, but it's broken. There's only a tiny amount there, whereas the bottom connects along this rail here, but it looks like it's there. So we might be able to get away with the bottom bit. So we'll try and see if we can just add some solder to this pad and see if it will take anything at all. Okay. So we might just need to heat my iron up a bit. I don't want to heat it up too much because I don't want to destroy these pads anymore, but not really taking it nicely. I'll try and add a little bit of flux first. If not, I might just need to increase the heat a bit more and try and get that just to flow a bit better, because the flux should hopefully help the solder flow, but it might also be that my iron's slightly too cool. But like I said, I don't want to heat it up too much because I don't want to melt it. It's quite a thin board and these traces are already kind of damaged, so I don't want to damage them anymore. So let's try. Yeah, so that's not really going how I want it to. So let's just try turning my iron up a little bit to begin with. Okay, that's gone a lot better. Still not very pretty, but definitely a lot better. Try and move this up and over. We'll just try and get this solder off of the other track, so at least it only stays on that one side. So even if it looks a bit ugly, at least if it's in the right place, we'll be okay. Okay, so that should hopefully cover both sides there. I'll just give it a little clean up first of all, and then we'll test to make sure that the actual pin is connected by just touching our multimeter in continuity against those two tracks the two little jumper wires there. And what I'll do is I'll go on the actual pin itself and then this side, and then we'll do the same again, pin and this side. Okay, so we know that's connected all the way through, so I can cut the end off of that leg. So this side doesn't look like it's going to take anything, but we might be able to scrape back just the pad in front of it and see whether we can use that to get it to connect to the leg. And then if we can scrape back just here slightly, expose some of the copper, and then maybe we might be able to just bend the leg over and then connect it straight to the pad there, rather to the actual like mounting point. So we'll see if we can tin up this area. So I'll come from the top and I'm just going to try and feed solder in, and hopefully it'll connect straight to that pad and then to the leg itself. That looks like it might. So it's alright, you can't quite see from the angle, but from where I am I can see that it's not quite come over the top of the leg quite how I want, so I'm just going to add a bit more. Okay, I think that is connected to the actual leg a bit better. So that pad runs, I think maybe to this, runs up underneath maybe this diode we looked at before. It might even connect to it, doesn't look like it though, and then runs underneath to this capacitor. So we'll try our multimeter again and see if it connects. And I'll go from the actual leg, so the actual leg itself that's sticking up, to the capacitor. Okay, so it just goes straight to that other diode, so I'm going between the leg here and then that diode, and there's our beep. So we know those two are definitely connected, just want to make sure that that's not bridging there. Doesn't look like it is, but it is close, so I'm just going to double check that with the meter just to make sure that those two aren't connecting there. No, so we're safe. Okay, let's try and get this back together a bit to test it then. So I'm just going to inject voltage again. I've got my leads, positives on the right, negatives on the left, and we'll just inject this and I'll have to let you know where the light comes on. Okay, so no light on the front. So what I think we'll do is we'll connect back to ground so I can get the camera out again and see whether there's any other problems. That's connected. Yep, okay, so we've got that. What I'll do then is I'll get the thermal cam out again and see if there's anything that's getting hot as a result. And it is just localizing. Oh. Okay, we had sound there. So are we working? Okay, it's kind of pulsing and changing and bouncing around. So let me just turn this off and then I'll have a look around and see if we can see what's causing that. So we're still getting hot on that diode that we initially thought was the problem. That's definitely not touching there, there's nothing coming through, I can't see anything. What I will do then is I'm going to grab a plug. Okay, so I'm back. I've got this barrel jack here which is connected to a power supply for the correct voltage. So we're just going to try plugging this in and see if we get anything different. So I've got the plug next to me so I can easily change it if needed. Set 7.5 volts, the same as the record player takes. So we're plugged in there and we'll turn the switch on. Just see if anything's happening. So we'll just turn the thermal cam on again and see. So there's still just a very deep heat spot on that one diode that we saw initially. We'll get the microscope in for this. Now I don't know whether you guys can hear on the camera, but it is kind of popping, like it's trying to work, but just can't quite make it. Okay, so I'm back at the desk with the record player, and I realised that I did a bunch of work and didn't press record. So what I thought I'd do is just stop and recap everything so it's a bit clearer where we're at, and then we'll continue through. So if we remember, this diode here was heating up and it seemed like a bit of a red herring. So it looks like it was the symptom of the problem rather than the cause of it. So I did a bunch of testing around. I took the diode off again and we still ended up with the same kind of issues. But as I took the diode off, I sat back and noticed that the light at the front of the record player had turned on. So there's a on-off light at the front here. So I'd taken the diode off, had it plugged in, was testing some things, sat back and the light was on, which then helped pinpoint maybe where the problem was, because it started working. So I gave it a little bit of a test, however there was no sound. So my thoughts were that this diode here actually runs into the audio output circuit, because the plate would spin and the Bluetooth would turn on, but there was no sound. So I left the diode off and did a bit of testing around. And that brought me to this section of the board here, which sort of makes sense because this cable here, just at the front, just at the bottom of your screen here, is which leads to the speakers. And there's a few capacitors and stuff around. So what I did was tested the capacitors for shorts, and they were measuring about 6 ohms, which is not a direct short, but was quite low. So I took each of the capacitors out and tested them one by one. They all tested absolutely fine. However, I left the diode off and tried injecting voltage to see what would happen. And what ended up happening was the left speaker of the record player, which if I just zoom out slightly, you should be able to see. So the left speaker here started kind of ticking, but the right speaker didn't do anything, which made me think that maybe it was something in the circuit for the right speaker that was causing the problem. Because as I was injecting voltage, I saw the voltage kind of ramp up, then drop down, ramp up, then drop down. So what I ended up doing was removed one of the audio amplifier chips on the right channel, which you can just see this kind of vacant pad here. So I removed this with my hot air and then put the diode back on, plugged it back in, light came on and it wasn't doing any weird pulsing and all seemed to work. So it seems like what has happened is the audio amplifier chip, this one here, has gone faulty slightly, and that was what was bringing the voltage down to ground, which is why it was struggling to turn on. So what I've got is I've got a few spares here, and we'll just put the new one on and we'll continue from here, and hopefully that should be this one fixed, which if that's the case, it was the diode here, which looks like when that blew took out one of the audio chips as well with it. So we'll probably move over to the microscope and we'll get this new one installed. Okay, here we are underneath the microscope, and here is our replacement chip, and it's just going to go on this pad here. So you see this little dot at the top represents pin 1, as does this little arrow here. So all we need to do is get our hot air station set up, and we'll just try and get this in place. What I'll start with to begin with is just try and retin these pads slightly, just because there might not be quite enough solder on it. So I'll just get my soldering iron and we'll just run it across, try and get those pads a bit better. So I'll start with just a bit of flux. This will just help the solder flow. There we go. Then hopefully we'll have some fresh pads to mount onto. So you'll see with this one that there's actually a ground plane in the middle there, so that'll just help the chip stick, but also works as ground as well. So it would possibly need just a touch more heat just as a result, because that will work as sort of a heat sink and we'll put it in. So those pads are nicely tinned. We can get our chip, get it orientated the right way around. What I'm going to do is just turn the record player around slightly just to make this a bit easier for myself, because then I can hold the chip on the two sides, and then once it's hot I can then just get it placed down. So I'll just get my hot air station. So we'll get this back together, we'll give it a test, and hopefully that's another one sorted. So I've just got it placed down on the floor here just to give it a test. Obviously the power supply that came with it was broken, so I bought just a universal one here. You can clearly say 7.5 volts, which is what this is. Apologies, my detonators have been fixing the car as well today. So it's plugged in the back. We just need to turn the switch on, so we'll give it a go. We'll plug it in. And we'll turn it on the back. What do we think? Is it going to work? So we'll get this in shot. So 3, 2, 1. Power on. There's that light. So we're on. So quite nice. Obviously you can just flick the lever up to get this out. Lift up this handle. We'll move it across. We see the plate starts to spin. We'll get ready and we'll lower down. Okay, so we're skating a bit. That could just be because the cartridge is knackered, but I think we had sound for a second. We'll just give it another go. Okay, so there's no sound, so it's skating. It could be the cartridge that's gone then. So what we'll do is we'll get it back over to the desk and we'll try and get that cartridge out, and we'll replace the cartridge, see if that brings it back to life. Okay, we go back to the desk. So I actually have some spare cartridges for these. I think it was like 3 for £3 or something. So they're quite cheap ones, but they look identical. I tried having a look at the actual needle itself, and it does look like it was missing the actual pin. So if I get the new one just under the microscope here so you guys can see. So it actually has got a little needle there which obviously goes into the grooves on the record. I don't think that's actually on the one that's attached here. It's hard to see, but I can't see anything poking out the bottom, so I think that is what the issue is that the actual cartridge is broken. I think it's a case of trying to get underneath the front here and then pinging it off, because it's sort of like clipped in place, but I don't want to break anything in the process, so we'll try and do it just off to the side here so we can kind of use this to hold it in place. Let me just double check, because yeah, so I think it slides in at the back and then the front clips in, so there's a bit just the front here which I think needs to lift up. And then hopefully, yep, the cartridge should just fall down, which we've got there. And then we just have some wires in the back here, so I'm just going to try and use my tweezers to pull these out. Looks like they're slightly glued in place as well. So the bottom one looks like it's a spade terminal. So with these, it's just, they're quite small wires, so just be careful when kind of pulling out. Don't want to break any of the wires. Yeah, fantastic. Okay, so if we bring this old one under the microscope, here's the one that's just come off. Get this in focus. Can you see it's missing the actual needle? Then if we bring in the new one, you can see that's there. So we put them side by side. Can you see it's actually missing the needle itself? I can take the cover off and then put it back in. So okay, I might be able to pull this around enough for you guys to see. So here we are. So you can see the bottom one has sort of like a spade terminal that touches the two, and we've got these little plastic covers. Then we'll slide it in place, and then we'll just there we go, clipped in place. So what we'll do, we'll pull that back over now that we've got the new needle in there, give it another go, and hopefully we'll have some sound. So we're all plugged back in again, so we'll undo the latch, lift up the arm, we'll bring it over, and we'll lower it down. Okay, still don't have sound. If you can hear anything, that's just coming straight off the needle itself. And obviously it's no longer skating. What I'm going to do is I'm going to grab some headphones and see whether it's playing through the headphones. So I've just plugged a pair of headphones into the front here, so we'll do the same again and see if we have any sound now. Okay, so that is playing through both headphones. So it's definitely working, so sound's coming through. So we just need to double check the output ICs. Maybe the one we just put on is on slightly wrong, and maybe the other one's blown as well, but just wasn't quite as bad, so we might need to just replace both of them. Okay, well, so we're back open again. We'll just test a couple of things. So we've obviously just replaced the IC. So what I think we'll start off with is we'll just test for shorts again around the bottom, considering that's where the issue came up originally. So I'm back in continuity, so we'll go on to this pin here, which is the negative of the power supply, and we'll go, so here's a couple of capacitors, so we'll just go negative onto here, which is a direct short, which makes sense, and then onto the positive side. And that also is showing a direct short. So something's still pulling that down. So what we might have to do is just remove that chip we put on again. To the big ground plane here again, so we go back to that negative side, and that shows us that's the ground plane, and we just go back onto the positive side, this capacitor here. Okay, so that's still showing a short, so maybe the other one has gone as well, and it's pulling them both down. 0.22. Okay, so I've been doing some looking around, and I've spotted something sort of immediately. So it looks like I've knocked off a resistor at some point, so that's definitely not going to help, which is just here. So you can see this resistor is missing, and if we take a look, we can see that comes into pin 1, which could well be sort of the input pin, because it comes all the way around and then in. So I think for one, that'll definitely need replacing. Fortunately, we've still got the one on the other side, so I might be able to find a replacement for it. That still doesn't really explain why the other side's not making any sound either, because I thought still one side would work. So I think what we'll do to start off with is we'll start by just removing the other side and see whether we still have the same issue. We can also borrow the resistor value, so we can see on this side that we've got capacitor and then resistor. Resistor shows 103, and that is the same orientation on the other chip there. So we'll use that as sort of reference to get that. So we'll start by just pulling this other chip off, see if the resistance value changes. Just double check the resistance as well. Now I'll come in to begin with, but I imagine it's going to be, well, immediately we have we immediately have open line on the positive side of that capacitor. So I think that is evidence that that other one was definitely bad. So I imagine it did take both of them with it when it went. Just as we're here, what's quite interesting is you might be able to see there's two holes here. I believe they're for adjusting the motor, and there'll be two different holes, one for the different speeds. So obviously records run at 45 or 33 RPM, and that, I'm guessing, is sort of like a serviceable feature that allows you to get it so that the speed is exactly accurate. Here we are back with Bonnaroo. What do we reckon? Do you reckon it's going to work? I'm feeling quietly confident. So we'll give it a go again. We'll undo, lift up, move over, volume up. We'll lower down. What's going to happen? No, still nothing. Okay, we'll revisit this back in a bit then. Maybe those two chips both are still not working. Maybe they're wrong. We'll come back to the desk again and we'll see what we can do. Okay, so we're back, and I've spent a bit of time chasing down this board, so I figured I'd recap rather than trying to show you all the way through because this video is getting a bit long. So I started with just testing the speakers themselves, just to make sure that they were all good. They were, so I did it two ways. I did one just by testing the ohm reading across the two terminals, came up fine, and then also just injected a tiny bit of voltage and see if they'd move, because as you add the voltage it should force the driver forwards and you'll hear it happen. So speakers were absolutely fine. I then tried plugging something into the aux port at the back and then the headphones into the front to make sure that it was a case of all sound wasn't getting out rather than just the actual needle itself, and that worked. So I had my laptop plugged into the aux at the back, a pair of headphones coming out the headphone port at the front, and it played straight through. So then I decided to start chasing the audio signals around the board. So I don't have an oscilloscope or anything to do that, so all I did was plug my laptop into the back, and then this kind of very janky approach is to solder on a negative wire of just a 1/8 inch jack onto the negative, and then use the other one just to prod around the board to try and see if I can follow the audio signal round. So I know that the audio comes in at the back where the aux port is, so we managed to find where it started, and it worked its way around the side of the board and then joined together here. So this kind of I kind of presume with this that it's not actually true stereo and actually summed mono, because I think the two audio paths join into one, work their way around the front of the board, plugged into this, and then you see as this touches different things will happen. So at the moment I'm just playing a 1K sine tone just out of the laptop. So this is the multiplexer chip. So this is the one that works a bit of a switch. So if we come to, I believe, this pin here, there's the 1K sine tone. I think we can turn it up a bit. There we go. And it should come back out here. And then it works its way around the board to these resistors here. So we've got it here. A bit interference there. Because we should have sound back out of this pin, I believe. Which we do, and it is controlled by the volume, it's just really quiet. So after looking at the pin out, I find that pin 1 needs to be high for the amplifiers to work. And what I found was when the headphones were plugged in, that voltage existed, but when they weren't plugged in, it didn't, hence why there was no sound coming out without it. So I start prodding around the board, following voltages around, try and work out where it comes from, try and see if I can work out how and why it's not there. And at this point here where I'm testing around the diode that we replace, the sound starts playing through the speakers because I've still got my laptop plugged into the aux at the back. So I try and work out what causes it. And basically, it looks like it's not fully connected. So although I tested in continuity between the diode and this diode that we replaced, and it beeped, it didn't work. So if anyone can explain to me how that makes sense, I don't know, because I thought continuity showed that it was connected. So basically what I realized is that it's lifted off the board slightly. The leg is not fully connected. Where all of the circuit traces started to wear away, it came off. So all I do is I run a trace wire between the two, which you'll see here. So I start to scrape back off of the copper pad, try and reveal some of the copper, get some solder down, and then try and connect it. Now this wire is absolutely tiny and it was a bit fiddly. It didn't really go very well. But in the end, you see I get the front end connected, then it gets connected to the board. And then I just double check with continuity again to make sure that it's definitely connected. Although it beeped last time and wasn't, this time it's certainly there. I then put it all back together, and then the next thing you'll see is us testing it, ready to see if it's finally fixed. And we're back again to test this out then. So what do we think? Do we think we're there? Is it going to work? Let's give it a go. So we'll power it on. We have our light. We can hear the speakers already. Amazing. And there we go. Yes. Fantastic. So a bit of a roller coaster, this one, really. So we had the diode that had gone boom. We had the two audio amplifier chips that had gone. And then we had that cold solder joint that didn't seem to connect, which sent me down a long rabbit hole. So all in all, it was a good fun one, but we're all up and running. Amazing. See you on the next one.